Gentlemen, welcome back to the shop today. The wonderful world of hot oil dripping down your arm. We have a Rexroth open center pilot operated hydraulic valve. So this is a size 10 4-2 directional valve. That means 2 position and 4 ways. And if we have a look here, what hasn't been wiped off because it's not a shitty plastic label, probably easier for me just to move this. We can see here, this shows us exactly what the logic element is. And I say logic element because this is exactly like an electrical logic element, only it directs the flow of hot oil. So this is 4-2, as I said. That means 4-way 2 position. We see there's 2 blocks here, 2 squares. That means there's 2 positions possible. What we have here is a pilot line on the one side of the valve, we have a pilot line on the other side of the valve, and we have a spring to ensure that if there's no pressure on this one or this one, that it is hard over in this position here. We see logically, if we have a look at this, and we just look at the schematic here, we see pressure in, P. See if we can focus, you fuck. Maybe not. There we go. We have pressure, P, that's in. We have tank, that's out. We have the work ports, A and B. So you could consider a cylinder on here. Now this is an interesting valve. One, it's not open center, but it's also not closed center. If you have a very simple log splitter, you're going to have a gear pump. It is constant displacement. As long as that thing is turning, it is putting out a fixed displacement of fluid. Now, contrast that to an axial piston pump. What happens with an axial piston pump? It has a swash plate, and that swash plate is actuated by a servo. The servo determines how much pump flow is going out. So, in those kind of systems, we have a closed center valve, because if we close off, if we block off the hydraulic flow, what happens is the swash plate comes to neutral. There is no more output flow from the pump, and the pressure goes to standby pressure. So you don't overpressure the pump because the pump is smart. That is in an axial piston pump. On a gear pump, it is dumb. It will spit its fucking guts clean out. It'll work as hard as it possibly can because it doesn't know any better. On that type, it's constantly putting out a certain amount of volume. So on that type of pump, you need to have an open center so that instead of the pressure spiking and screaming over the relief, it goes through the valve, through the open center of the valve, and back to tank. Instead of going over the relief valve, and then you have an extreme amount of pressure, you get a lot of heat buildup across that. Say you have a 100 horsepower system with a gear pump, that 100 horsepower, if you have a closed center valve, that 100 horsepower goes screaming over the relief, you get 100 horsepower of heat. So it doesn't take long before you burn your machine right down to the ground. So this is a good valve for an axial piston pump. Servo actuated. I also wanted to mention, what the hell is a servo? Because the servos are used in electricity, they're used in RCs. You know, we've all heard servo. So what's the difference in a hydraulic system between a cylinder and a servo? Because these axial piston pumps are servo actuated. A servo is an actuator that has feedback. It's got a feedback loop. So when you have one of those little steering electronical ones, that's a servo because it has feedback. It knows its position. And in an axial piston pump, it has feedback internally, so it knows its position, so that it's not turning its guts out trying to make up oil when it's already at relief pressure, when it's set. When the system pressure is at whatever the servo is set at, it de-strokes and gives you no flow. That is the kind of valve that is going to work with that. This is the kind of valve that's going to work with that system because it is, well, it's neither closed center nor open center. It is closed in that you put an actuator on here There's only two positions. You put an actuator on here. After the actuator has bottomed out, it's still getting flow. So what would you use this for? Well, you'd use this for some sort of clamping device, because you wouldn't want it to clamp and then potentially leak off and then unclamp. So you're always sending pump pressure to this guy. So it's either clamped or wide open, and it gets locked in that position, and we're continually sending it pump pressure in order to maintain its openness or its closedness. So this is kind of an oddball valve. Normally what you would see for a directional valve on a cylinder is a 4-3. So that would be 4-way and 3 position, and the center position would either be blocked right off in an axial piston pump, or it would be open center in a gear pump. Further to the analog of computer logic, we see here the valve from Rexroth is characterized just the same way that if you purchased a MOSFET or an op amp, it would be characterized as well. We can see here we have all, hey, that looks familiar to you Pixie Wranglers, doesn't it? So when you buy valves from reputable sources, that is the beauty of them, is they are characterized. When you buy a valve from Prince Hydraulics or something like that, you don't know what you're getting. It hasn't been characterized, and it even tells you the required surface quality of the valve mounting face. It shows you the parallelism and the surface finish you need. I mean, that's the difference between buying, say, a log splitter from the Hazard Fraud or from Princess Auto. None of the components are characterized, versus buying a Komatsu or a Caterpillar piece of gear. Orders of magnitude difference in the price, but the reason is all the components have been characterized and engineered, and they're skookum. That's the difference. That's the difference. But we can see here, we could build, if we had oodles of money, we could build a hydraulic computer, and it would be completely characterized through the data sheets. If you're familiar with electric solenoid actuated valves, you might be wondering, why in the hell would you have a pilot operated? That means that, well, this is essentially a relay, but a hydraulic relay. So you need a small pilot pressure to actuate the full force. And why would you want that? Well, because say you have a bank of 30 implements in the cab of a machine. Now, you don't want this big valve in there doing the ka-chunk, ka-chunk in the machine. What you want is just a little toggle switch or something of that nature, just to give you a little bit of pilot pressure. So this pilot-operated valve acts just like a relay. Now we're into where we scrape the patina off the iconography, and we can see this is just a schematicized representation of what's actually going on. Here's the spring on this side. It's showing on this side. So now we know that this tank and port B is actually going to be underneath on this side. So just beware. This is just the logical element. This is not the actual embodiment. A lot of guys get hung up by that. They get sort of confused, and when they get it back together, it would be nothing to put it on the wrong side because it says so on the schematic. So you got to be cognizant of that what's on here is not necessarily what's in here. We'll take out the spool, being careful not to blow the lands out here. So this beautifully machined and ground spool, very, very fine machining. Of course, the tolerances and the fit is critical in hydraulic controls. The thing is, it's metal on metal in there, and it's not the metal what is sealing the hydraulic oil. There is designed leakage through here, but the hydraulic oil itself is sealing. It is viscous enough to seal those very fine clearances. And we see a feature that helps it along is these lands here. Now what happens is any oil that wants to flow past those lands it ends up being like a Tesla one-way check valve. You ever see those one-way check valves? It's just a bunch of reeds all stacked up, and it actually acts as a check valve. So what happens here, if oil is trying to flow past here, it gets swirled up and caught up in these lands. They're also called, I believe, centering slots, if I'm not mistaken. And here we have some feathering slots, so that instead of when the valve starts to move, we get a bit of flow from one side to the other before we get full on chooch, full flow right past. We can see this is a very simple valve. We got a seat there for the spring. Essentially what we do is we put oil into one side, shuttles the valve over, it connects P to A and B to T, or the obverse. It just swaps them around. All you got to do is follow the arrows here. So we're either extending a cylinder or retracting a cylinder or potentially turning a slow motor. Now, in order for motor control, there needs to be a crossover relief valve, otherwise it blows up and so forth. But in essence, you could get this to turn a motor one way or the other, or move a cylinder one way or the other. So that is a beautiful piece of valving, and we can see, have a look at this. It has been flame hardened on the outside and then ground after the fact. So that is an expensive piece of kit due to the very high tolerances required to seal oil. Same thing in here. There's the bore. That would be all machine bored and then ground out internally. So there's the blanking plate, and it's not actually a blanking plate. It's connecting a couple of ports here. They bring in flow from the pilot line and chooch it over to both sides. Something like that. We see here. So here are the pilot ends, and they must go up to here and connect up. So you could have another valve on this that would do something like relieving, or a load lock valve or something like that. Some sort of different logic element. And what you can do is you take these valves and you can stack them up to do different things depending on your application. So we see that we're not doing anything different with this application. So we're just jumpering these two ports together to make sure that flow goes to both of these ports, which it doesn't really matter if just one was on there, but that's what it is. So that, you have a look at that, how simple that logic element is. Nothing to it, just a big beefy cast steel block, maybe cast iron. Yeah, maybe cast iron, some gray ductile iron. It makes sense that it'd be ductile iron because there's nodules of carbon in there, nodules of graphite in there, and when you machine it, and then it just, graphite is an incredible lubricator, so that would prevent this from wearing out prematurely. So what can go wrong with these? Very, very little. If you're following the specs, they have a cleanliness spec, they have also a amount of flow and a pressure spec. So if you're within those specs, this valve is going to last forever. If you're outside of those specs for cleanliness, say you open up some lines and there's some goop what gets in there, some chunks of rock or some gold nuggets or whatever, that's the only thing that's really going to damage this valve. And 99% of the time when you get a valve that's fuck-aid, it's because somebody left a ball bearing in there. Now the other thing that could happen is it could overpressure if another part of the system is not, if another valve isn't working properly. Could get some hydraulic hammer, that sort of thing. The other thing that can happen is if it sees too much flow, the pressure drop across this valve is too great. You start to get cavitation across the lands. So this would start to look a little bit dull, and it wouldn't seal as well. You'd have more and more internal leakage. That would create more and more heat buildup. You could catch that if you're troubleshooting a hydraulic. I didn't have this when I started out. They just started coming out. So you had to troubleshoot everything the hard way. But partner, if you can get your hands on one of these guns, all of a sudden the troubleshooting gets so much fucking easier because you follow the heat, and the heat is where the problem is. If you have a component that's hotter than everything else, that is the problem. It is working the hardest. Why is it working the hardest? Well, because all of the flow is going past it instead of going to the cylinders. Makes sense, right? Heat buildup in any component indicates whether it's an electronic component, whether it's an electrical connection, whether it's a hydraulic implement. If it's hotter than everything else, remember that oil is circulating. Everything should be roughly the same temperature within a few degrees. If it's hotter than everything else, something is going on. So there you have it. Very simple valve. This would probably be a $1,500 piece of engineering right there in the meat of your hand. Now, what do? You got a hydraulic problem, you find a hot component. Okay, so first things first. You got to troubleshoot the easiest thing first. So is that valve, is it a pain right in the cant to get at? Are you going to have to pull 1,800 lines and get it come along and pull stuff aside and get your Filipino buddy double jointed in there upside down? You know, if that's the case, you want to go and have a smoke and a bong and a blintz, have a sip of coffee, figure out, is that absolutely, here's the thing, a lot of people too lazy or too busy or whatever to look at the schematic, read through the schematic and understand. If you have the schematic, you take your time, partner. You don't got to understand the whole thing, but you break it down into bite-sized pieces until you understand what is going on with the valve. That's mental toughness. A lot of guys don't have that, where they'll just go and pull valves and changing parts. But you're chasing your tail. You want to find out what systems affect what valves and work through it step by each. Because that way you don't look like a fucking idiot with egg all over your face, you know, schmoo running down your face because you took off the wrong valve. Okay, so we found a hot valve. Now what do we do? First things first, you look for the easiest things first. Chunks of schmoo in there, busted shit, it doesn't want to come out. Why doesn't it want to come out? There's something in there, or it's worn out or something. Okay, so next you clean this off good and proper. If you're in the shop or maybe you're underground or whatever, if you can't clean it the best you can, brake clean, spray it off, try and keep it clean. These are, you know, they tell you it's got to be clean room spotless. It doesn't have to be clean room spotless. It was fucked when you took it off. And if you put it back together proper and it's not fucked, you're saving the day. You put it back together and it's still fucked, try the next thing. You know what I'm saying? You know what I'm saying. Okay, so what you do is you clean this off as best you can. You have a look at, real close look at all the mating surfaces. Make sure the thing is not cracked, nothing fucked. I've been fucked 2 days scratching my head. What was happening was there was a control bank of valves, and it was sleeved. Instead of being solid, it had sleeves. The sleeve, what would happen is you'd be steering the thing or doing an implement, it would work fine, and then all of a sudden the implement would fuck off. What would happen is, as you're working the thing, it would get hot, and you're working the thing, the pressure would rise. The sleeve had a tiny little crack in it. It would seal up when it wasn't under too much pressure. As soon as it got hot and there was enough pressure, that crack would open up just temporarily. The implement would fuck off, scare the shit out of everybody. Then it'd close back up, and the thing had worked like a hot damn for a while. So there's lots of head scratchers like that, but you get in there and you have a real good look to make sure there's nothing cracked, nothing funny going on. So we get in there and we get our light in there, and you have a real good look down there and make sure there's no schmoo. We're going to put her back together. I like to use some light grease if at all possible. If all you got is thick grease, then use just thick grease. This valve stuff, valve lubricant, some guys swear by this. This is a silicone. Okay, this is silicone. It's different. It's got polydimethyl siloxane and dimethylsiloxane. So it's not oil based. This is inert. And it's very, very thick. So this, some people say that you can only, this is ridiculous, mind, but you'll hear it. You can only lubricate O-rings, Buna N O-rings, with O-ring lubricant. Now, O-ring lubricant, the specially branded stuff, is silicone. It's not, it's inert. But you can just as easily do that with petroleum jelly or grease just to lubricate it, because think about this. If these got eaten up by Vaseline or oil, every hydraulic system on the planet would be leaking everywhere. So these are relatively inert. They do harden up. They do harden up with heat. But if all you got is grease, grease is going to be fine. So I'll just show you this. Yeah, you see that? Real thick, real tacky. I like using this. And also, is it miscible? Is this stuff miscible with the standard hydraulic oil? Maybe. Maybe it is. Maybe it ain't. However, this stuff, absolutely. Engine assembly lube. Yes, absolutely. It is miscible with standard hydraulic oils. So, it's a case, bigger the gob, the better the job. Just goop it in there. It ain't going to hurt nothing. And you jam that in there like so. You got to be careful sometimes because these are very, very sharp lands. So just be aware, it could cut you. You know, you drop it and you go to catch it. Just let her fall, partner. It ain't worth it. You can clean the schmoo off it after. Okay, so you see how tight that is? Nice and tight. But it's not a friction fit. It's not, there's a clearance there. So now we got that. We got the valve seat. We got that guy. One last thing. Okay, this valve, we didn't find anything wrong with it because there was nothing wrong with it. It even got okay on there. But if we didn't find anything wrong with it and we put a new valve on the machine and lo and behold it works, a lot of guys or some guys would go ahead and tag this good used. I urge you not to do that. Either, if you can, chuck it in the scrap bin and get a new one on order, or if you're kind of in a cheapskate jackpot operation, put it on the shelf as used, untested, good question mark. Because that way the guys are thinking that maybe it's not the greatest part. It came off of there for a reason. If you label this good used and you haven't tested it, you're doing the next guy a huge disservice. And chances are you're going to be the next guy. Thanks a lot for watching. Keep your dick in a vice.